Hey everybody, welcome to another calculus video. This is section 2.2. The beginning of chapter 2, 2.1 is just kind of an overview. You can read through that, but 2.2 is the introduction to specific graphical and numerical limits. And so that is what we're going to be talking about today. So the idea of a limit, what is a limit? A limit is basically a y value that a function looks like it will reach as we get closer to a given x value. Okay, and so that's not a mathematical definition at all. I'm just trying to give you the idea. All right, so for example, if you've got a function that's going along like this, and this is the x value we're interested in, as we get closer and closer to these x's, what happens to your y's? Your y's get closer and closer to that point right there from both sides. That would be considered a limit. All right, well, obviously we don't need a limit definition really for that type of situation. It's just a function and it's continuous. There's no hole or anything like that, so there's no problems. But so limits become interesting when we have functions that have singularities or points that you can't just plug in. That's when they really become interesting, okay? And so I want to show you a couple of examples of limits. The first one is going to be numerical, and so the example here is I'm going to give you the function f of x equals the sine of x divided by x. And I want to find the limit, if it exists, limits don't have to exist, as x approaches 0. Okay, the limit of f of x as x approaches 0, because obviously you can't plug in 0 here. If you plug in 0, you get a 0 in the bottom, and that's not okay. All right, and so what I'm going to do is I'm going to make a table. I'm going to have x's here and f of x is here, and I'm going to plug them into my calculator. And the deal with limits is you have to approach from both sides. So I'm going to think of this as kind of my x equals 0 point. This is my number line, okay? And then I'm going to pick points that are close to 0. So if I start from the right-hand side, if I pick the point 1, what happens when I plug that into my function? Now make sure that you're in radians. Make sure you're in radian mode. All right, plug that in, get sine of 1 divided by 1, plug that in your calculator. All right, and you get 0.841. And then I'm going to pick a number that's closer to 0. Remember, this is a number line. So I'm going to pick like 0.1. If I take 0.1 and plug it in, 1/10 and I plug it in to my function, sine of 0.1 divided by 0.1, I get 0.998. If I plug 0.01, 1/100th in, I get 0.9999. All right, and if I wanted to be really precise, I could pick another one and I'd get lots of 9s here, okay? Well, clearly, these numbers look like what? These numbers look like they're getting closer and closer to a y value of 1. Remember, this x value is 0. We're looking for the function value. Okay? So let's do this. Clean this up a little bit. X equals 0 is up here, right? And so the f of x is getting closer and closer to 1, maybe. But only from one side. I got to come the other side too. And if I plug in -1 and I plug that in, then I end up with the same thing, 0.841. If I plug in -0.1, I get 0.998. It's not surprising because sine is an odd function and x is an odd function, so two odd functions give you an even one. I get 0.999, etc. Okay, so it looks like from both sides as I plug these numbers in, I'm getting closer and closer to the x value, the y value, excuse me, the f of x value of 1. And so the way we write that is we would write LIM for limit, lim. Underneath it we put x goes to 0 of f of x. That's the notation. So this is red, the limit as x goes to 0 of f of x. And we would say that is equal to 1 because as x approaches 0, y is equal to 1. Now remember, f of 0 does not exist. Right? F of 0 doesn't exist. You can't plug in 0 here. You get 0 on the top and 0 on the bottom. That does not divide away. All right? That doesn't work out that way. 0 over 0 doesn't make any sense. And so f of 0 doesn't exist, but the limit does exist, and the limit's equal to 1. So that brings us to our first point here, is that the limit can't tell you about the function value. I kind of joke around and say that the limit is a shallow function because it doesn't really care about who you are. It just cares about what you look like. All right, and it looks like the function is going to a y value of 1 as x approaches 0 if you plug numbers in, even though when you actually get to 0, it just goes away, right? There's nothing there because it's not defined. So the limit is, don't be hard on the limit though because it's shallow, because it can't tell. It's not designed to be able to tell. It's only about appearances, and it has a role to play in calculus, okay? And so that's why the limit is important to understand, because it is a different idea. So limits are a very complicated idea when it gets to being mathematically technical, but the picture of it is pretty simple. So let's take a look at pictures here. All right. Here's a function. This function here is, we're going to call these f of x's, and I will say that this worksheet, I'm not happy with it because it kind of leaves some stuff out that it shouldn't. This should be an arrow going that way. There should be an arrow going this way. And then this should say f of x next to it. It should not just say lim. That doesn't mean anything. Okay, so it's got to have acting upon something. So let's take a look at this. All right, as x approaches 3 minus, what does that mean? When it says limit as x approaches 3 minus, what does that mean? That means from the left-hand side, from the negative side of 3. So 3 is right here. The negative side of 3 is this side, right? The positive side of 3 is this side. So we're looking at one side at a time. The notation for that uses this negative here if we're coming from this side only, and it uses the plus if we're coming from the right-hand side only. So if you look at the y values from the left-hand side only, I'm constantly at this level. I'm at the level of y equals 2. It's a constant, okay? And so this value is 2. However, if I'm coming into the x's from the right-hand side of 3, then I'm down here on this part of the graph, and where am I down here? I'm down here at negative 2. So my limit as x approaches 3 from the right-hand side is negative 2. Well, if it looks like I'm going from 2 from one side and negative 2 from the other side, then obviously I don't have a limit, because your limit would have to be the same from both sides. I can't give you directions to get to GGC, and if you leave from my house, you get to GGC, and if you leave from your house, you wind up in downtown Lawrenceville. That doesn't work, right? Regardless of what direction you're coming from, you got to wind up in the same place, or else you don't have a limit. And so the way we express that is we write DNE. DNE stands for does not exist. Okay? Don't write no solution, and don't write empty set, right? Does not exist, because that's a specific terminology affixed to limits. And then what is f of 3? Like when you actually get to 3, what happens? We have a point right here. We get 1. Right? So here we are, where if you come from the left-hand side, it looks like you're going to one thing. If you come from the right-hand side, it looks like you're going to a different thing. So the limit doesn't exist, but then the function value is neither of those things. Again, the limit cannot tell what you're doing. The limit cannot tell what actually happens at the point 3. It can only tell what it looks like is going to happen. We have to look at each side. We have to look at each side. Okay? So if you come up here to number 2, all right, the graph's not very good again. This is f of x. So now we're looking at the limit as x approaches negative 2. Negative 2 is right here. There's not a hole here, but even if there was, it doesn't matter, because that point is where it looks like you're going. And so as you approach negative 2 from the left-hand side, your y values go up to there. They go up to 2. as you approach negative 2 from the right-hand side. Your y values go up that hill up to 2. So we say that the limit, therefore, because from the left and the right you get to the same spot, the limit is equal to 2. And in this case, if you plug it in, you get equal to 2. So this is the best case scenario when the limit and the function value are the same. But again, that doesn't have to happen. Okay? So what I'd like you to do now is pause the video for a second and you guys try problem number 3. Problem number 3, here's f of x. You're approaching 1 from the left, from the right, and then do you have a limit? All right, pause the video and come back and let's talk about it. Okay, so what did you get? As you approach positive 1 on the x-axis from the left-hand side, what does your y values do? Your y value goes up, 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 up. Looks like it's going to this hole. That hole is at 1, 2, 3. So my limit is equal to 3. However, as I approach from the right-hand side, my function kind of does this little dip and then comes up to that point. That point is at positive 2. So if from the left-hand side it looks like you're going to 3 and from the right-hand side it looks like you're going to 2, your limit does not exist. All right. But because this is a solid point, your function value is actually equal to 2. So your function value is the same as the right-hand limit, but again, that doesn't matter. Okay? That doesn't matter. All right? So if we come down here, I'm going to jump down to the next page. All right, on the next page, we have a couple of things here that we're not going to deal with right now. These functions that are running off to off the page, down or up to infinity, you'd actually have asymptotes here. There'd be an asymptote here, vertical asymptote, and there'd be a vertical asymptote here. We'll deal with those eventually. Those are in chapter 2. We won't deal with them until much later than that, though. And so don't worry about that. But the other ones, the first half of the page here, all right, numbers 1 through 9, you can do. Don't worry about the rest of these guys. Okay, but 1 through 9 you can. So again, why don't you pause the video and see if you can't come up with. Now notice some of these step you through it. Here's left-hand side, right-hand side, whole thing. But then for number 9, it's just x approaches 1. It doesn't ask you left and right. So you don't have to write those down if you can determine it cleanly. Okay? Here they ask you right, and then they ask you the whole thing. So you're going to need to do it whether you write it down or you do it in your head. It doesn't matter to me, but you're going to need to be able to evaluate left and right because they have to match up, right? So why don't you try 1 through 9, pause the video, and come back in a few minutes, and I'll give you the answers. Okay, so what do we get here? Looking at number 1 coming from -6. -6 is out here. As you approach x equals -6, what's your function doing? It's going up this ladder here to -1. But as you approach -6 from the other side, you're going up the hill here, and you're going all the way up to 1, 2, 3, 4. And so from the left-hand side, you get -1. From the right-hand side, you get 4. That means you do not have a limit. All right. How about -3? Well, -3 is right here. As you approach -3 from either side, what happens? Well, you're going down to that hole. Now remember, as a limit, I don't care and I can't tell if there's a hole there or not. It doesn't matter if there's a hole or a point because the limit doesn't care. The limit doesn't know. Don't be hard on it, right? So 1, 2, 3, that hole is at -3. So from both sides, it looks like you're going to -3. So your overall limit as you approach x equal -3 is equal to y equal -3, okay? How about -1? -1, we're coming from either side. Again, this is -1. So as we come from the left-hand side, we're going up this hill. As we come from the right-hand side, we're going up this hill this way. It looks like we're heading towards this spot right here. It doesn't matter there's a point up here, and it doesn't matter there's a hole right there. What matters is it looks like we're heading to y equals 2. And so from the left-hand side, 2. From the right-hand side, 2. And so therefore the overall limit is 2. All right, and again for 1, where does it look like we're going? It looks like we're coming down to that point, we're up to that point, and then you actually have a point there, but I don't care. Limit doesn't care, but it is a limit because from both sides it looks like you're going to -1. So again, the limit is the y value as x approaches a particular given value. Okay? So there's a couple of examples there graphically. There was an example for you numerically. You're going to want to go through and try those in my math lab, and then I will post a couple of worksheets as well for you to practice on. The basic idea of limit is relatively simple, but you've got to get it down because it's the underpinning for much of what we're going to do for the first half of calculus. Okay? Hope that helps. We'll see you later.